Oh, yes. Hi, I'm live already. Uh, I can start to talk? Yes? All right. Okay, yes, cool. Good morning, Jay Focus. I'm very happy that all of you are here. I thought, okay, first spot in the morning after the party yesterday could be a tough spot, but no, the room is quite full now. I'm very happy, and everyone here is exactly the right person that should be here, I think. And the talk today is called Curse of the Pharaohs, Rethinking the Testing Pyramid with Test Containers. And yes, we will talk a bit about test containers and see some test container stuff at the end, but it's not the main focus. So I hope you didn't expect a full-blown test containers talk. That's not here today. We will talk a little bit more about testing in general, but also how test containers maybe changes testing and how we approach testing. For this talk, I wanted to have a cool picture of some pyramids for the title, so I looked a little bit around, and this is from Description de l'Égypte Antiquité, and this is a very old book from the scientific expedition that joined Napoleon back on his Egyptian campaign. And in a way, this is the birth of modern Egyptology, and the first time we started to apply scientific methods to archaeology as well, but it was still an age of romantic science. And if we look at computer science and software engineering, a lot of what we consider our knowledge, our best practices, our culture is maybe a little bit closer to still the age of romantic science and mythology as well, with a lot of anecdotal stuff and not always really pure software history. So we will do a little bit of software archaeology today. My name is Kevin Wittek. I'm a software engineer at Atomic Jar. It's the company that is now also supporting the Test Containers open source project. And I'm one of the maintainers of the Test Containers Java open source project. Who here is a Test Containers user already? Cool, quite some hands. And who wants to be a Test Containers user, maybe? Already thinking about it? Cool, even more. And maybe this will have some convincing arguments for you. Some years ago, I also started my PhD on something completely unrelated, but at least computer science. But this brought me a little bit more into scientific thinking, maybe, and looking at how academic community does things, and also in a way motivated my talk. There is a very nice paper or lecture I heard and I read from Donald Knuth. We know Donald Knuth from the famous book The Art of Computer Programming, and also as the inventor of tech. And he read a paper by a software historian or computer science historian, and it was called The History of Software from Martin Campbell. And there is one sentence in there. Over time, software history has evolved from narrow technical studies through supply-side and economic studies to broad studies of application. And then Donald Knuth says the moment he read this, like he touched his eyes and they were wet because he started to cry. He couldn't believe that this is how the historic science of the history of software has changed. Because now we're not looking at the software itself, but only the outside, the applications. This is now the state of computer history in a way. And if you look into how history is approached in different fields, in different disciplines, it's the same around many disciplines, and it's a conflict of historians between internal and external history. The external history is how your field influences society, influences the world. The internal history is the history in itself from within. And computer science history in the last years, the academic computer science history especially, changed to extremely focus on just this external history, how software and programming and computer science changes and influences society and the world, but not how computer science inside influences itself. And one of the fields that is different, interestingly, is mathematics. For whatever reason, we have a really good internal history in mathematics, and this allows us to find out really interesting things. Like, for example, Fibonacci numbers. We know Fibonacci discovered those numbers 1200 Anno Domini, but in India, they have been already discovered 200 years before Christ as well. So very interesting. Those kind of things appeared in different timelines, or not times, it's the same timeline, but at different times, and we can connect them and see something interesting there. Yes, we're not looking at the video. I want to skip it actually. Yes, cool. Cool. So let's look a little bit at the history of unit testing, because this one is especially interesting, and it's not even that easy to find out how unit testing really came to be. But one really good source for this is Kent Beck, and especially how it influenced unit testing in Java. So Kent Beck was originally a Smalltalk programmer, came from this community of Smalltalk object-oriented programmers, and they had already a very specific testing culture in Smalltalk. But in Smalltalk, the testing was not automated, how we know it nowadays with something like JUnit. But you have this interactive manual environment, stateful environment. And if you have ever worked with something like MATLAB or R, you will know this, because there also you have this stateful workspace. You will run functions, and they will maybe change things in the state, and you run the functions by hand from the terminal, and you have this explorer that shows all the variables you have right now. Certain Python environments have similar features in Jupyter notebooks, and that back then was the way to test very exploratively. And he thought about this, and this was very good for them in the Smalltalk community, and he thought about, okay, how can we map this to Java? And that's when he came up with JUnit in a way. And there the workspace, the stateful workspace, became the class. The variables you had in the workspace became the instance variables we have in those classes. The tests they wrote by hand become the methods. And then the assertions that they before did by just manually asserting stuff, by looking at it, by printing it, they became the assertions we know, assert from Java or whatever. And yeah, so this object-oriented unit testing framework he developed around 1992, and this was in Smalltalk still. Yeah, and when he joined this C3 project, which we all know is also the rise of extreme programming, he brought this concept of object-oriented unit testing in Smalltalk with him, and they did this all there with Smalltalk. But back then he also thought every team should build their own unit testing framework using this object-oriented metaphors. But then we know this very famous flight he had with Eric Gamma, where they flew to the Uppsala conference, and there he was already practicing test-driven development, and they, during the flight, developed the first version of JUnit in a test-driven development style. Then they gave it to Fowler at the conference. He was also at the conference, to Martin Fowler, and he said, and they said, okay, here, check this out. That's what we built on the flight. Do you like it? And he liked this, and then somehow from there it spread, and it became really part of the Java community. Okay, so, but I said he developed JUnit using the test-driven development approach. So he was already practicing test-driven development at this stage. And when he talks about test-driven development, he is talking that also in test-driven development it's important to test things at different scales, like at the really low level, but also higher up in the layers, or more from the outside, more end-to-end testing, whatever. So he never, especially in his original talks and writings, he never talked about TDD as a unit testing philosophy, just a general testing philosophy. And what is very interesting, that if you look at JUnit framework itself, and I think these numbers are for JUnit 4, the composition of tests, like 40% of the tests of JUnit, and JUnit was developed with TDD, goes through the public API, and just 60% are working against the lower level objects. And you can say those tests that go through the public API, they are functional tests, maybe they are even integration tests, depending on how you define it. But yeah, that's how the test suite for JUnit looks, at least at the time of writing when Kent Beck explained this. Okay, so question we all can think about: why do we test? Why do we as software developers, assuming most of you are software developers, why do we test? Yeah, maybe to find bugs, or maybe to encode the specification and what we know about the program to safeguard against future regressions. When someone changes something, someone does a refactoring, then we have the tests that tell us, oh no, this now lead to something we don't want it. Or sometimes we write tests because someone told us to, because the boss told us to, because we suddenly have the requirement, okay, we need to have test coverage of 99% in SonarQube, then we have to think of code that calls all the getters and constructors or whatever. And then some people maybe don't even test, I don't know. Like some will say, we have testers that test, I'm programming, then I'm throwing it to the testers, then they test, and then they tell me what I have to fix. And I personally, I'm in line with this last point. Testing is for me the easiest way to get feedback about the correctness of my code during development directly. So it's really the most convenient way for me. So that's why I don't think about testing in the term of testing, it's just part of development for me most of the time. And then there was this very nice paper, it's more like a small article, but they also published it as a paper, from Kent Beck and also Gamma, and it talks about JUnit and the influence of the JUnit framework on the industry. Every programmer knows they should write tests for their code. Few do. The universal response to why not is, I'm in too much of a hurry. This quickly becomes a vicious cycle. The more pressure you feel, the fewer tests you write. The fewer tests you write, the less productive you are, and the less stable your code becomes. The less productive and accurate you are, the more pressure you feel. So many of us might know this cycle. Programmers burn out from just such cycles. Breaking out requires an outside influence. We found the outside influence we needed in a simple testing framework that lets us do a little testing that makes a big difference. So their hypothesis in this article is that by having a tool like JUnit now at our disposal, testing is much more convenient for us. If it's convenient enough, we will do it more. And then we start to enjoy it, and we see the benefits for us as developers as well. So that's very interesting to think about this, how the tooling we have available changes our programming and development paradigms. And I would like to agree with this hypothesis, by the way. All right, so we talked a little bit about unit testing already, and mostly about JUnit, which many connect with unit testing. But what actually is unit testing? And if you try to look at definitions for unit testing, it's not that easy to find actually clear definitions. And I looked at some scientific papers and academic sources about definitions, and this one I found, which is very interesting from IEEE. Unit testing tests individual software components or a collection of components. Okay. Collection of components, that sounds like an integration test already, but okay. Testers define the input domain for the units in questions and ignore the rest of the of the system. Okay, that's also strange. Now here in this definition we need to have testers because they need to define the input, unless maybe the developer acts as a tester. Unit testing sometimes requires the construction of throwaway driver code and stubs and is often performed in a debugger. Like, I don't know, this definition was strange for me. So yes, I sometimes use a debugger while I'm trying to fix the code so I can fix the test, but I would not say my unit testing is performed in a debugger. Strange. But there is no clear definition. Also in academic papers, whatever, they have all different definitions. And then I tried to also find actually academic papers how the industry defines unit testing for themselves. And I found this one, which is a survey of unit testing practices. And there it was an empirical study where they made a survey with different teams and different projects, and they tried to find out, okay, on what kind of aspects do they agree? And there was the agreement that unit testing should focus on the smallest possible unit. So that's what they all agree on. But I don't know why they agreed on this. That's not clear from the survey. But there was a big disagreement regarding the degree of isolation already. So is this small unit you want to test allowed to talk to other objects, to other processes? People had different definitions for this. Very fuzzy. And then I tried to find out what is the first time we heard the word unit test. Maybe we can start from there. Or unit in the context of computer science and programming. And I was not super successful. But the first reference I found, and which might be the first reference, is in a paper called Automatic Software Test Drivers from '78. And there, an IBM manual is referenced, Automated Unit Test, AUT system. It's some kind of system developed by IBM. And it's, for me, not 100% clear what this system does. Is this unit testing in the way we think about unit testing today, or does it something different? I know you write those tests in a different language than the program you are then actually testing, but I couldn't find this manual. So if any of you has access to historic IBM manuals and maybe can, after the talk, provide me access to such to the manual, that would be awesome. Then there is a book from '79, The Art of Software Testing, that for many is considered a very good standard book. And in '79, there was a chapter that on testing. It was called module testing. Okay, in '79 it was called module testing. Then in the '90s, we had the rise of all those X-unit frameworks, thanks to the Agile community, extreme programming community, also to Kent Beck. And then there are some of this group that say, okay, the unit in this context of the X-unit test frameworks means a unit of test code that can be executed. So that was one of the definitions back then. And then something very interesting happened. There is a second edition of this book, 2004, coming out, and there they rename the chapter on module testing to module unit testing. So I don't know, somehow the definition of unit testing really evolved over time, and not sure how and why this happened. All right, okay, a little bit about the unit testing itself, and now we want to dive deeper into the pyramid as a metaphor, as a symbol we use in software development. So this is likely the initial inspiration for the unit testing pyramid. That is the food pyramid, the very classic one from the United States Department of Agriculture. I don't know, from the 70s or 80s it is, I think. And nowadays we know, of course, that this is not correct, and it's an oversimplification, and also a wrong oversimplification. And it was largely motivated and pushed by lobbies in the US, like the agriculture lobby, for example. That's why we have all the agriculture products at the bottom, like they are good, yeah? So that's interesting. Let's keep this in mind, and we will see a connection later, a very clear connection. This is one of the first versions I found, the test automation pyramid by Mike Cohn, that appeared sometime between 2003 and 2009. It's not that easy to pin it down exactly. So there is the legend that he originally showed this to Lisa Crispin in 2003, and Martin Fowler tells this. Okay, maybe we can believe him, maybe not. Where we really see it then the first time from Mike Cohn is in his book, Succeeding with Agile Software Development Using Scrum, and there he uses this image and explains it. And yeah, so there was this so we have to understand, this pyramid symbol came out from the Agile community. And there was this pre-Agile mythology that tests are very expensive to write, and we cannot automate all the levels. Like automation on the UI level is maybe not even possible. So that's where the industry was at this point. And now the Agile community came in and tried to change these assumptions and say, okay, we can automate on all levels, but we have to think about the levels differently. And okay, UI is clear. We at this time already have tools like Selenium coming up, so you can use those. And they are a little bit more expensive to write, but they are possible. That's why we should have fewer. And then unit is not that clearly defined, actually. And then service he defines as also not that clearly. So it's similar to UI tests, but they don't go through the UI. So through some kind of very outside API. That's how he defines it. And he gives a very weird example to me. So he said an example for a service test, yeah, that what we might call integration test nowadays. A service test is you have a calculator and you have a multiply and a divide service, and you want to test those. And this is a service test, and that's like, okay, what is a multiply service? That is a pure function, so why isn't this a unit test? I don't know. Those simple examples, they really break down very often, and they are not helpful for us to get the understanding how this works in the real world, in my opinion. Then from 2006, I found this drawing from a whiteboard from Jason Huggins. Jason Huggins is the inventor of selenium. And yes, he drew this to also communicate the place of selenium in the context of the test suite. And here, that's why I think it all is connected to the food pyramid, because he says the top, the UI test, salts and fats used sparingly. So that's how he compares it to the food pyramid, where you also have the salty, fatty stuff at the top. Yep. And yeah, the different layers, you have the unit test at the bottom. You don't have something called integration test. Here they call it functional test. And in this pyramid, the layers are connected to the technology you use. So if you use PyUnit, then it's a unit test. If you use doc test or pit, pit is, I don't know, something like Cucumber, I think, in the Python world, then you have a functional test. Yeah? But you write it still using a testing library. Also, early, and very early other visualization we had that is not a pyramid are these agile testing quadrants. So Lisa Crispin, we heard it earlier that Mike Cohn talked to her already about the test pyramid, and Brian Marick, they published this, and I think Brian Marick had the initial very simple version we see on the left, and then Lisa Crispin had the a bit more advanced version, and she published this in Agile Testing, a practical guide for testers and agile teams. So what I like about this visualization a lot is that in contrast to the former ones, this is really two-dimensional. The former ones, the pyramid, it was a two-dimensional graphic, but you had to sort in the tests along a singular dimension. So you just had the y-axis to put the test somewhere. And having a single dimension is probably not really enough to describe the different characteristics of a test sufficiently. And here you can already place them in the different quadrants. And then you see, okay, if a test deals with certain things, then it becomes a different test. So like the tests that are like functional tests, they are there to support the team, and they are maybe still also business facing. So it's they try to implement the specification from the business side. And we can automate them, or maybe we have to do some of them manually. And then we have like the other spectrum where like performance and load testing, like the business generally doesn't know anything about it. It's very something very inherent to the technology team itself, and it's there to stress the product itself. You use probably different tools for this, but it's also all testing. Then we have a 2012 version from Martin Fowler, and this looks very much like the Mike Cohn version. What I like a lot about this is that he has a sentence coming with it. If my high-level tests are fast, reliable, and cheap to modify, then lower-level tests are needed. So we see already now a context associated with this pyramid. The context of, okay, the bottom is fast, the top is slow, the bottom is cheap to program, cheap to maintain, and the top is more expensive. And if this context in our software development project is different, then it will potentially not create such a pyramid shape, because this shape is informed by the context. Then we have from 2014 Simon Brown. He is giving a lot of talks about architecture and those kind of things, and he always tries to question certain industry truths and says, okay, like maybe we should rethink those things. And he also realized when he wanted to rethink the test pyramid that we have an extremely fuzzy definition of unit test, of integration test. Maybe I can come up with a clearer definition, and that will help teams reason about them more. So he said clearly at the bottom, if you're just testing a single class, then it's a class test. Then you have a middle one where you test your components and your services in connection with each other. however you define component and service now in this context. And we see the distribution could be the same. So there's no reason why you should have less service tests than tests of individual classes. Depends on your needs. And then he also agrees that the tests that go through the UI should be a little bit less, because they are nowadays still a little bit more expensive in general. We had 2018, this very nice visualization from Spotify, and that gets adopted by more and more teams now, I think. And it comes from a blog post they wrote about where they explain how Spotify tests their microservices, what tools they use, and how their test suite is composed. That they don't have a pyramid, they have this honeycomb. And they use, by the way, test containers to do this big integration layer. So they have some implementation detail tests, which are the very classic unit tests. Then they have a lot of integration tests. Then they have something at the top they call integrated test. Integrated test is a concept from J.B. Rainsberger, from the testing community. And they are an anti-pattern. The integrated tests are those tests where you are not really in control if they are green or red, if they fail or if they will pass. What are examples for those? If you are having some shared environment where your team deploys applications, other teams deploy application, then suddenly your test might fail because someone else mutated the state of this environment. So those are, you should avoid those, but maybe you want some of them because they are like the last ultimate integration of the final system you will have running. And the integration tests, the good integration test should be extremely isolated. They should not suffer from this. They should be able to spin up all the dependencies they need in isolation, use them in isolation, then throw them away. So that's why they use test containers for this. And they say for them that's so much better than the classic pyramid, because since they have these microservices, the microservice in general has a higher ratio of integration service to business core as compared to a big monolith. So microservices in general talk with a lot of other microservices, other systems. So that's why they want to have more integration tests, because they also have more integration code in their microservices. And as an additional benefit, they say having this high amount of integration tests allows them to do more extreme refactorings as compared to unit tests that use extensive mocking. Yeah? So if any of you used extensive mocking in the past, you might know that these will sometimes hinder refactorings a lot. We have a very similar concept from a friend of mine, Asaf Mezika. Back then he was at Logs.io, now he's at Scream Native. He calls it the diamond model. Really same idea, also using test containers for this integration layer. And he also says their teams benefited a lot. They also use microservices a lot. They benefited from going to a test suite that uses more integration tests. It gives them a better confidence in the correctness of their system. All right, and one last model, the testing trophy. This came from the JavaScript community. From Kent Dodds in 2018. The top part looks like the diamond or the honeycomb we saw before, but he reasons about the bottom as well. So having static code checks, for example, a type system is also a kind of a test. What the compiler can do is kind of a test, and it allows you to capture certain error classes. And probably he did this to advocate for TypeScript, I don't know. So, okay. Looking at all those things, we see, first of all, that there is no real clear definition of what those unit, integration, service, component are. Like, everyone uses it differently, but somehow we have this rough understanding on which we agree, but it's very, very, very fuzzy. And my hypothesis is that tests are extremely multidimensional, and we should think about them in a multidimensional way. So we have this singular dimension we see in those pyramid visualizations on the y-axis. And this is generally one of those steps in this dimension is unit test versus integration test, which is probably not a hard step, but more like a gradual shift. Yeah? And already here, how to define those borders and how to define this dimension. This is already very, very hard. There are some other dimensions we can understand better. So opaque box versus transparent box, this we can understand. So do I have to assert my tests by looking at just the state I can observe as a user of the system, like through the public API, or do I have a way to assert certain changes and state in the system by looking inside the system itself? Then we have an open box test. And sometimes both are good and they both serve different purposes. Then in process versus out of process. A classic Spring Boot test generally runs in process because it will spin up the sprint context, but your tests will run in the same JVM as a Spring context. And this makes testing sometimes much easier because you can test the methods directly, versus out of process where you have to go through the REST API, through the public API, whatever. Then again, out of process gives you sometimes more flexibility to test other things in combination with each other, or more realistic to how the system behaves in reality, in production. And then there is this idea from Martin Fowler, which I like a lot, and he says there are solitary tests and sociable tests. So the solitary test is if you're testing a single object or unit, whatever unit is in this case, in complete isolation, and then there's sociable tests where this single object can call other objects. Okay, are these other objects then completely represented in memory or not? That's a different story. So how I generally define integration testing is if my tests interact with external system and dependencies. So this most of the time just means interacting with an external process. For me, that is an integration test. If I have my code calls into the database, which is its own process, if my code has to call over the network, has to interact with the file system, which is its own process. These are integration tests for me. If I have two objects, like the multiply and the divider object, and I have my other class that tries that those interact with each other how you want for a formula, that is not an integration test for me. But that's my personal definition, so we can add one more now to the list of definitions. But Martin Fowler also has a very good point in one of his blog posts about interactions with external components in unit tests. If talking to the resource is stable and fast enough for you, then there is no reason to not do it in your unit test. Okay, and resource he means, for example, database in this case. And I don't know what at this point this means anymore for our definitions of unit tests and so on, so we are lost there. All right. But the nice thing, the really nice thing I took from all this research with me was this sentence from the article from Beck and Gamma about JUnit and how JUnit changed testing. Breaking out requires an outside influence. We found the outside influence we needed in a simple testing framework that lets us do a little testing that makes a big difference. And now my pitch to you, yes, is that Testcontainers is maybe such a tool, maybe such a framework that allows us to break out of existing patterns, of existing testing patterns, and makes us allows us then to rethink the testing pyramid and use it to our needs. So, to those of you who don't know what Testcontainers is, that's how it looks in Java code. That's how you can use it. It's a Java library, although we also have it in different languages. But in its core, it's a Java library for instrumenting Docker containers using an object-oriented API, and mostly for your testing use cases. So the idea is that from within your JUnit test, you can just define the containers you want to interact with, because you need them for your integration test. You get an object, and then you can just start and stop the object. It's like doing Docker run, Docker stop, and so on. The basic class we have is generic container. You can use this class with any Docker image. So any image you have that runs in a Docker container, you can use with Testcontainers. Just throw it in there, it will work. And then you have to configure it a little bit so Testcontainers can instrument it more effectively. We can, for example, say with exposed port. And what this will do is it won't do this port one-to-one port mapping you might have done before when using Docker from the command line or Docker Compose, where you say, okay, I want to have port 8080 mapped to port 8080. That's not what Testcontainers does, because what will happen if port 8080 is already in use because you are parallelizing or other tests are using it or another application uses it, then your test will fail. So if you do this, you're directly creating an integrated test, which we don't want to have. So this is extremely discouraged by Testcontainers. So we try to allow you to we try to make doing the right thing easy. Yes. So that's why what Testcontainers does in this case, it uses the publishing port feature from Docker. So it's when you say Docker -p 8080, then what Docker will do, it will automatically publish it to a free port, ephemeral port, most likely over 50,000, over 60,000. And this will always work. It's very extremely reliable. And then Testcontainers has an API that you get the map port. And then you just inject this into your system under test, and then everything is good. Something else, the starting. So when you start a Docker container from the command line, starting the container itself takes less than a second, microseconds likely. Because what does starting a container mean? Starting a container means creating the process, creating the namespace, etc. But there is a difference between starting a container and the application inside the container being started or being ready. And Testcontainers tries to help you with this by having the start code wait until the application inside the container is ready, so that your test can interact with it, so you don't have any race conditions. How does Testcontainers do it? There are a couple of, we call them wait strategies, and the default one in this case will just wait that Testcontainers can connect to this port, can make a TCP connection, but there are more advanced ones, sophisticated ones. You can wait for a certain HTTP response. One that works very well with certain kinds of images is waiting for certain log messages to appear. That sounds like not a very elegant way, but it is for some images that are out there really the most stable way. For example, for the Postgres database, crazy but true. And yes, then when you stop the container, Testcontainers will clean up everything afterwards for you. It will automatically remove it, so you don't have any pollution of the system, any more containers lying around. This is a manual way to start and stop containers. We have integration in different testing frameworks also, although you don't really need to do it. Doing it manually with a start command is completely fine. But if you want, you can use the test framework integrations, and then the life cycle of the container will be bound to the life cycle of the tests. In this case, this is a JUnit Jupyter integration, and the way I defined it here, the container will be start and stop per test message, okay? And if you would make the field static, then it will be per test class. Many people that start using test containers initially do it like this because it feels kind of natural to really integrate in the test framework. But in general, I would say be very careful with this approach, because starting a container is much faster than starting a virtual machine. But still, it takes some time, it takes some overhead. And if you have to start the database for every test method, it's nice that you definitely don't have test pollution because you have a brand new database, but still there's a cost involved. And it's an unsustainable cost if you have it across the test suite, I would say. So it's much better to deal with test pollution on the logical level instead of the infrastructure level, meaning like you do it classically, with cleaning up afterwards, with using a different schema, if you're using something like Kafka, with using different topics per test and so on, to avoid test pollution there. Yes. Okay, yes, some more information about test containers. So test containers Java, which is the first developed test containers library and the most developed one, was released in 2015 by Richard North, the guy in the middle. And we are 3 maintainers, core maintainers of the project, Richard, Sergey, and me. And this is all of us at my wedding. 2 years ago it was, or 3 years, not sure. My wife is there, she would know probably. 2 years, okay. Yeah, so that was the first and only time we 3 met in person. And then afterwards the pandemic happened, and yeah, so we will not meet again in person, so bad things seem to happen afterwards. The library is 100% open source under MIT license, and we have over 54 releases by now, and over 300 contributors, so we try to be an open and collaborative open source project where others can contribute as well. And yeah, used by many thousands other projects on GitHub, and also by really big open source projects like Spring, uses us for testing. Quarkus uses us for testing. Quarkus uses test containers for their Quarkus dev services, for example, that uses test containers under the hood. Micronaut uses test containers for testing. Juke uses test containers for testing. Like most Java projects that have an integration testing need use test containers by now, which is of course super awesome. Yeah, as I said, we are first and foremost, or we started first and foremost as a Java library, but nowadays there are re-implementations in different languages as well. We have a Node version, Python version, Go version, and they are all part of the test containers organization. The feature set might differ between versions, but I read now a couple of times on Twitter in the recent weeks, people that had to switch from Java projects to Go projects, and they were quite sad because they love test containers so much. And then they discovered, oh, there's also test containers Go, cool, and that made them happy. And it makes me happy if it makes them happy. Something recently happened that also made us as the test containers maintainers extremely happy is that we appeared on the ThoughtWorks technology radar, and we appeared in the adopt category, which is the best category you can have. And what they say about test containers is, we think it's a useful default option for creating a reliable environment for running tests. Our teams have consistently found this library of programmable, lightweight, and disposable containers to make functional tests more reliable. Perfect, yes. And I hope those of you that don't use test containers yet will try it out maybe next week or so when you come back from the conference, and will learn the same for you. All right, some of the features we will roughly talk about, and I think we won't have time for a deeper demo, but yeah, you can find on YouTube many talks of us where we show also demos. And I had a very deep dive demo on Monday. Some of you were there. And some of the generic features are support for any kind of image that we saw in the examples. It's a generic container support or generic image support. But then we have special modules that implement some syntactic sugar, some configuration for you that makes it then easier to run certain images for your integration testing needs. So for example, for databases, relational databases, NoSQL databases like Cassandra, or those stream processing applications like Kafka, Pulsar. And we try to do the heavy lifting for you that sometimes is necessary to make an application work nicely in a container for testing. We try to implement those things for you that it makes it easier to directly test it. The different cloud vendors that have their cloud mocks that run as containers and that are kind of emulators or simulators for the cloud services. We have modules for those. If you're already using Docker Compose in a way, in a custom way maybe, you can also reuse your Docker Compose files. We have an abstraction for this, although we generally recommend to adopt doing it the test containers way instead of with Docker Compose, because it's in some ways more flexible and also more stable. Support for Selenium, where the browser runs in a container. Chaos testing with Toxi-Proxy, where you can put this TCP proxy between containers and then start to introduce toxics, so errors into the network stream, like latency, jitter, drop packages, and so on. Very recently, we got support for Kubernetes with K3s, so that you can test your Kubernetes application, Helm-chart deployments, whatsoever. There is a third-party module by a colleague of mine. It's called Kind Container. It's even more powerful than the K3s module. Kind Container is Kubernetes in Docker. We also use this for testing as well. And that's pretty cool. Yeah, and many more. And the base features that you directly leverage when you use test containers is this dynamic port binding and the API to get the dynamic ports. That's what I said. We don't have the fixed port. We bind to free dynamic port, and then you just get them. The wait strategies, so test containers waits until the application in the container is ready. Then out of the box, a Docker environment discovery, so it doesn't matter on which operating system you are and which variant of Docker you have installed. Test containers will automatically detect it and configure itself sufficiently. So we are platform independent. Like on Windows, we will detect, okay, it's Docker for desktop in WSL2, so I need to speak with the named pipe instead of the Unix socket. Because there are quite some difference with all those different Docker distributions. They try to be transparent, but if you as a technical library interact with Docker, you will find out those are leaky abstractions very often. So the question might come, we also support non-Docker container engines, but not with an automatic environment discovery. So we have configuration properties for you, or environment variables you can configure if you have something like Colima, for example, and you can generally make it work, but we can't give first-class support for all kind of alternative Docker setups we now see rising on Docker for Mac and Docker for not Docker for Mac, on Mac to replace Docker for Mac because of the licensing changes, yes? But in general, if you have any trouble, you can ask in our Slack, you can create issues, and so far we were able to get most environments running, actually. Okay, this is just a quick overview of the modules we currently have. I'm not even sure if this is all modules. And then something very important to take from this list is if there is a technology you are using and you want to use with test containers and it's not on this list, that doesn't mean you need to write a module or you need to wait that the module appears. Very often there is no module because a generic container is sufficiently good as an abstraction. So especially images that are very container native already, they just work with this generic container abstraction. You just say, okay, this exposed port, and I want to wait on this condition, which you can do declaratively when creating the object. And then you're good to go. All right. And yeah, now would be time for a demo. So we have 4 minutes, but I would rather give you some time for questions instead. So thank you very much. I hope you learned a little bit about the history of testing and unit testing and test pyramids. And if you are already using test containers, you are now even more convinced to use it more. And if you are not yet using it, you are now intrigued to try it out. Thank you very much. Any questions? Yes? So there was a question if there is a way to use your own application inside the container, your custom application or whatever. And yes, you can do this. It doesn't matter. It doesn't even need to be a Java application. So if you have a Docker image, so if you build a Docker image, then it's trivial because you just use generic container, you specify this Docker image, and then it's fine. It also works if it's just in your private registry or whatever. It can pull it because it uses the Docker authentication mechanism for this. And that, of course, means that we can write, for example, smaller end-to-end test or whatever using JUnit and test containers and do a complete out-of-process test of our application and its dependencies. And our application doesn't even need to be Java because it's abstracted away, it's running in the container. Okay, yes? So the question is why I didn't talk about what the book guided. What is it? Guided by tests or object-oriented design guided by tests? Isn't this the name? Yeah. Yeah. Yes. And very, very nice question, thanks. So there is the idea that you start out with an integration test, with a very, very outside integration test that will, of course, fail because you haven't implemented anything yet, and then you will go inside, so you do an outside-in implementation, and while you go closer or more to the core, down the layers, you start to write unit tests for those small details. But you keep the integration test also, or? Yes, but you keep the integration test. And I think that's a great idea. That's how I very often develop software. So I start thinking, okay, calling through the public API, is that what the integration test would look like? And that's what I would test that this happens. And then if it's trivial to implement this directly, then I will just directly implement it and I will stay with the integration test. If while doing this outside in development, I find out, okay, there are details I have to now flesh out, classes I have to flesh out that are much more complex, then I will start to write unit tests for exactly those details. So I think it's a great strategy and it's a great combination how you can do TDD, and for certain needs you do integration tests, for certain needs you do unit tests. Thank you for the question. Okay, yes, I think we're also out of time officially, or yes? Cool, then thank you very much. I will hang around at the conference today, of course. If you have any other questions about test containers, come and see me, talk to me, and have a nice day. See you soon. Bye. Thank you.